Hello, my friends, and welcome back to the You Can Do TV channel.
A dry dock works at its best when a vessel gains the exact support and clearance it needs, and the AVRA. GR at Onyx Neorion shipyards shows how that balance is achieved during full maintenance preparation. The operation begins with teams positioning the ship for the lift, guiding it so the hull aligns with the dock blocks. Once secured, the water level is lowered and the vessel settles onto its supports, giving crews full access to every surface that needs work. That shift from water to full support always looks like controlled strength in motion. The next phase moves to hull cleaning, where accumulated marine growth is cleared to expose the steel beneath. Layers come off quickly under high-pressure systems, revealing areas marked for treatment. Feels like the ship suddenly shows every story it collected at sea. After cleaning, technicians spread out around Avra. GR for inspections, checking structural points, cargo hold interfaces, and underwater fittings. A few viewers might be surprised by how much activity happens at once, almost like the vessel becomes a small worksite of its own. Surface preparation follows with abrasive blasting at selected zones. Fresh coatings are then applied to protect against corrosion and ensure smoother travel through water. There's a moment in this stage that almost feels like giving the vessel a renewed attitude. While coatings cure, mechanical crews handle valves, thrusters, anchors, pipelines, and deck machinery, each task fitting neatly into the shipyard's schedule. Some reactions might lean toward amazement at how quickly different teams rotate through their assignments. As the dock is flooded again, AVRA. GR lifts gently and returns to water. The vessel completes its dry docking cycle with renewed durability, standing as an example of how Onyx Neorion shipyards and M/Maritime keep fleet reliability moving forward. Seeing the boat-mounted pressure washer at Dockside Divers Inc. cut through 6 months of marine buildup shows how its jet strips away layers fast, and the sudden force in that spray can make you pause for a moment. It almost looks like the washer wants to chase the hull down the pier. Containers are stacked tightly yet handled without a hitch at Navantia Cartagena. The scale of these machines is staggering, yet the workflow appears seamless. Straddle carriers shuttle containers efficiently, moving cargo from quay to storage with exact timing. That swing of the crane seems slower than expected, but each motion is perfectly calculated. Dock workers communicate constantly, ensuring no container is misplaced and every schedule is maintained. Automated systems track each container, monitoring weight, destination, and stacking order. It's impressive how technology and human effort merge to prevent costly errors. Forklifts and trucks assist in final placement, completing the chain of operations smoothly. Somehow the whole process looks almost too easy for the complexity involved. At the end of the day, the terminal remains orderly, ready for the next wave of incoming vessels. Peljasac bridge sections are carefully transported from China, secured for shipping. That pile grows faster than you expect, almost like the load has endless stamina. How does the S-81 remain perfectly aligned while sliding into water? The submarine S-81 at Navantia Cartagena slowly moves toward the water, guided by experienced operators ensuring a precise launch. The controlled descent looks deceptively calm, yet the engineering behind this maneuver is intense. Tugs coordinate seamlessly to position the vessel over the floating dock. That push forward seems lighter than expected for such a massive structure. As the hull touches the water, careful adjustments stabilize the submarine, keeping it aligned with launch pontoons. Specialized equipment monitors the pressure and buoyancy in real time, preventing any misalignment. It's remarkable how the teamwork and machinery handle such enormous weight with apparent ease. Engineers confirm the submarine is securely afloat before disconnecting the support systems. This is where decades of shipbuilding skill truly show. The S-81 now rests ready for next trials.
Tons of steel are joined together to create a ship that moves with precision at sea. The USS Gerald R. Ford represents unmatched naval power and operational capability. At 106 feet and 112,000 tons, it can conduct 220 airstrikes per day from its 2 runways while supporting 4,000 sailors and Marines. Seeing such engineering marvels in action makes you pause. This is next-level naval dominance. The ship's steel was ceremonially cut, forming part of the side shell units. The keel was laid, marking a pivotal milestone in constructing the lead ship of its class. Modular construction enabled different sections to be built simultaneously, improving efficiency. Imagine coordinating thousands of tons of steel across multiple workshops. Yeah, that's intense. After years of assembly, the Gerald R. Ford was christened at Newport News Shipbuilding. Each section was carefully integrated, systems installed, and quality checks performed to ensure maximum operational readiness. Its completion represents a leap in aircraft carrier technology, replacing the inactive USS Enterprise after 51 years. The coordination, planning, and sheer scale here are mind-blowing. As the ship joins the U.S. Navy fleet, it exemplifies the cutting-edge combination of engineering, logistics, and military strategy. Operational readiness. Standing over 4 meters high and nearly 3 meters wide, the hybrid rudder blade built at Navantia CEFAN highlights how polymer elements can form a full-scale naval component with surprising efficiency. The team prepares 17 AS-printed pieces, each reaching up to 130 kilograms, arranging them so the structure gains its initial geometry. Seeing those huge printed blocks line up that smoothly caught me off guard. Once positioned, the traditional workflow is paired with additive manufacturing, allowing the assembly to advance without the complexity of older layouts. An intermediate fiberglass coating is applied, giving the body a stable layer for later reinforcement. A final carbon fiber coating then strengthens the entire blade, completing the new construction strategy. The contrast between lightweight polymers and the final 500 kilogram result had you blinking for a second. Every stage aims to refine this first full-scale prototype and push the concept of a 3D-assisted rudder closer to service. Kinda looks like a sci-fi ship upgrade midway through.
Large aluminum frames push the DMU-200 gantry to show how its wide travel turns complex jobs into steady motions. The machine brings a long X-axis reach to position each frame, letting the spindle meet surfaces without hesitation. Kinda feels like the head moves with a quiet confidence. Stiff rails support the aluminum as the tool carves broad faces. Chips exit through dual conveyors so the cutter keeps a clean track. That clean sweep hits unexpectedly satisfying sometimes. The optional 90-degree head shapes inner pockets before the column lifts for tall features. Access from both sides helps loading, and final passes leave the frame ready for inspection before it moves to shipping checks. Steel plates are aligned intact for the 20-meter span girder beam used in a railway bridge project, then placed for FCAW welding along each seam. Welders follow the programmed path to build up layers with consistent deposition, controlling heat to avoid distortion. Seeing the bead grow along that length makes the scale really hit you. Quality checks verify fusion before assembly. Lean insert widths on the CorroCut QD show how low alloy steel can be parted with tight control using 1, 2, and 3 mm tools. The setup guides each insert through SS2 and SS2541 bars, while internal coolant keeps the cut steady. Material use drops sharply thanks to these slim profiles. That narrow slice looks quicker than expected for such dense steel. Operators move the QD holders across 20 and 32 mm bars to compare stability at 140 meters per minute. Feels like the tool just glides through without hesitation. Each feed rate highlights how smaller widths save stock while still keeping the groove firm. Almost looks like the cutter prefers tougher sections. These results confirm consistent control across insert sizes. At Yutong Bus & Coach, advanced systems shape every bus with precision and efficiency. The laser three-dimensional material bank feeds multiple laser devices, with switching under 30 seconds, keeping production moving seamlessly. Robots then palletize components, integrating laser scanning and intelligent technologies for consistent accuracy. CNC bending robots handle key components automatically, feels like the machines almost predict the next move. Profile cutting and punching merge technologies unique to the bus industry, followed by 3D profile laser cutting, achieving precision up to plus 0.25 millimeters. Robot flexible tooling enhances welding efficiency by over 30%, while front and rear wall frames employ offline simulation for flawless assembly. The three-dimensional tooling warehouse supports 12 bus platforms with automatic transfer, reducing switching time to just 6 minutes. Welding dislocation and intelligence systems ensure multiple welding modes and 98% pass rates. The largest electrocoating line, RFID-enabled, boosts bus body transfer efficiency by 60%. While overhead conveyors move air conditioners quickly and accurately. Glass gluing robots and intelligent battery loading streamline subassemblies. This setup looks almost too smooth for such large machines. Powerful grommet laying equipment at UOS handles the oversized strands used to create the 420 mm offshore grommet. an item holding multiple world records for circumference and load rating. Coils of steel rope are unspooled and aligned before being fed through the main winding system, which forms the continuous loop by guiding each pass into a tight layered structure. Seeing that thick cable curve like a giant rope toy feels unreal. Operators monitor tension to avoid uneven buildup, while the drive rollers keep the heavy material moving. The looping drum rotates steadily until the full 94-meter circumference is completed. The weight of the piece alone makes you wonder how they maneuver it without a fuss. Clamps secure the loop for finishing, where protective wraps are applied to high-stress zones. Final checks measure diameter and verify the massive 60-ton piece weight. Shipbuilding at Sevmash runs across multiple departments, each coordinating tasks efficiently. The level of coordination here is impressive for such a large facility. Milling operations and shop, 4 shape parts essential for every vessel. Mechanos assembly teams assemble complex components with precision. Archive management preserves detailed records for all ongoing projects. Personnel management oversees staffing and candidate placement, ensuring positions are filled efficiently. Cultural activities, competitions like Korabolochka, and veteran observers maintain community involvement. Each department operates according to Sevmash's standard procedures, reflecting experience and systematic organization. Sub-assembly processes, including milling, assembly, and material handling, ensure the shipyard continues producing vessels reliably. Feels like the human-machine coordination here sets a high benchmark for efficiency. A rare moment in metalworking happens when a single brass knob at a small workshop becomes the entire focus, and the CNC mill takes on the unusual task of recreating a lost fireplace control. The setup highlights how one machine at a time can return a missing part back into service without needing full-scale production. Feels almost like the mill is stepping in as a stand-in craftsman for a forgotten piece. To move toward shaping the brass blank, the machinist positions the stock in the vise and loads the program used previously for another job. Since this is only a replacement part, no new optimizations are added, keeping the approach direct. The first passes remove the outer diameter to define the basic cylinder, and chips sweep outward as the cutter carves steady paths. That amount of chip flow builds up faster than you expect from such a small part. Next, the CNC transitions to profiling the knob's contour. Its steady movements outline the curved sides and center section that fit the fireplace shaft. Though the toolpath isn't tuned for maximum efficiency, every cut holds the dimensions needed for a perfect fit. Didn't expect such a compact cutter to hold its line this consistently. A slight vibration at one corner reminds you how even a simple part still pushes the machine to stay firm through each movement. A pocketing sequence follows, forming the recess on the face of the knob. The mill clears material in tight circles until the cavity reaches depth. The pattern leaves clean walls suitable for later hand finishing, if required. Finally, the shaping routine concludes with a smoothing pass across all surfaces, giving the brass the crisp look needed before off-camera steps, cross-drilling, and tapping the hole for the set screw that locks the knob onto the shaft. That last sweep almost looks like the brass is taking a breath before heading back to real use. The part leaves the vise ready to replace the original lost component. At Pilsen Steel, the act of pouring molten iron is a spectacle of controlled energy and precise timing. The molten metal must maintain a uniform temperature to flow correctly into every part of the mold. That glowing river of iron looks like it carries the weight of the world in its flow. The video captures a single, continuous pour, emphasizing the team's coordination and the careful manipulation of heat and gravity to form a flawless casting. The ladle, filled with molten iron, is guided into position over the mold by the overhead crane. Operators signal each movement with sharp, deliberate gestures to ensure the stream of metal lands exactly where it should. That pull before the pour always looks like a power move you wouldn't expect from something so fluid. Every tilt of the ladle is calibrated to maintain a steady flow, preventing splashing or uneven filling. As the iron begins to pour, it glides smoothly into the mold, filling each cavity completely. The flow rate is critical. Too fast could trap air, too slow risks premature solidification. The bright orange glow of the molten metal highlights its intense heat and density. The team's attention is unwavering, monitoring the pour to maintain consistency. That flow looks thicker than you'd imagine, almost like molten honey, but with real muscle behind it. Small adjustments in the ladle angle keep the surface level and prevent turbulence, ensuring the final casting will be structurally sound. The molten iron advances steadily, tracing the shape of the mold with precision. Even slight deviations in the ladle path could cause defects, so focus is key at every second. Operators guide the crane gently but decisively, allowing the liquid metal to reach every corner without interruption. Even in a simple single pour, the combination of human coordination and machine reliability is striking. The careful positioning of mold sections ensures a uniform distribution of metal throughout. As the pour concludes, the ladle is carefully withdrawn, leaving a perfectly filled mold. That final tilt almost looks like the iron is taking a bow, finishing its journey. Temperature differences across the mold are monitored to prevent cracks during solidification. The casting will begin to cool and solidify, but in these moments the focus is entirely on the seamless, continuous pour. The team's synchronization and control of the molten flow demonstrate the effectiveness of experience and technique in creating high-quality iron castings. The short video highlights how a single, well-executed pour requires attention to detail, careful control of machinery, and skilled operators. You can sense the quiet intensity behind every movement in a short clip. Every action, though seemingly simple, contributes to the success of the casting. Even a minor adjustment in ladle tilt can change the flow path dramatically. That molten stream moves with more authority than you'd think for such a brief moment. The balance between speed and stability makes this pour look effortless. Watching the liquid iron settle reminds you that metal in motion is raw energy carefully guided toward a solid, functional form. The 1.6 million square foot ULA factory handles rockets of immense scale. The CNC machines achieve tolerances that few factories can match. The scale of this place makes every component feel like it carries the weight of the stars. Metal sections are carefully aligned on automated platforms, with robotic arms performing precise handling and welding. Advanced CNC machines shape critical structures, integrating multiple technologies to ensure tolerance and performance. That welding sequence moves smoother than expected for such massive parts. Each subsystem undergoes rigorous testing before it even leaves the assembly area. Technicians inspect and verify components at every stage, combining human expertise with automated measurement systems. Subsystems like avionics and propulsion units are prepared and tested in parallel, ready for integration. Seeing these rockets slowly take form is satisfying. Flexible tooling systems allow quick adaptation between different vehicle configurations, increasing efficiency and minimizing downtime. Materials are transferred seamlessly across assembly zones via overhead conveyors, ensuring continuous workflow. Protective coatings and surface treatments are applied with robots to maintain quality standards. Before final assembly, alignment checks and simulations ensure structural integrity under operational stresses. The overhead conveyors keep complex assemblies moving without any bottlenecks. Every step emphasizes precision, safety, and repeatability. Feels like each stage could launch tomorrow, even though it's just on the floor. The factory integrates storage, tooling, assembly, and testing into a synchronized system that maximizes productivity, while maintaining the highest aerospace standards. Engineers at BMW's Battery Cell Competence Center in Munich select materials for cathodes, electrolytes, and separators, optimizing chemistry interactions for each battery cell. Prototype cells are then assembled and analyzed for performance, energy density, and charging capabilities. The thorough handling of these components makes every cell a powerhouse in a compact package. Next, cells undergo testing for peak output and lifetime, ensuring reliability in final battery packs. Seeing the alignment of components reminds you how detail drives performance. After validation, the mass producibility of future cells is evaluated using high-quality industrial machinery. Even small adjustments in prototype assembly have a noticeable effect on overall efficiency. Sustainable sourcing of lithium and cobalt is checked before production. The entire process, from material selection to system integration, guarantees each battery contributes to efficient, long-lasting electric vehicle performance. That workflow almost feels like a miniature orchestra of energy and expertise. 250 staff and dozens of ovens at Walzenirle produce rollers up to 130 tons each. The precision required to handle such massive components leaves little room for error. Across 2 factories, employees coordinate every step, from melting in 8 induction furnaces to rolling and heat treating in 17 specialized ovens. CNC machining and high-wear mold casting ensure each roller meets stringent standards. That static casting alone demands a combination of strength and finesse you wouldn't expect from solid metal. Vertical and horizontal centrifugal casting lines allow versatility in production. Quality control is continuous, guaranteeing that every roller leaving the plant performs reliably in industrial operations. Seeing this scale in motion feels almost like watching giants at work.
Each day, around 7, 200 aircraft wheels touch down on Schiphol's runways, and KLM wheels and brakes ensures they are ready for the next flight. The team carefully inspects each wheel, spotting wear and stress that could affect performance. The first task involves cleaning the wheels to remove dust, oil, and debris accumulated during landings. Once clean, technicians measure tread depth and check for structural cracks, ensuring safety standards are met. It's wild how quickly these wheels go from dirty and worn to almost new. Wheels that require replacement are taken apart, and brake discs and hubs are examined for heat damage or metal fatigue. Components passing inspection are polished, reassembled, and fitted with new tires. Specialized machinery balances each wheel, replicating conditions of high-speed landings. Meanwhile, Core Geisen oversees the workflow, coordinating humans and machines to maintain a rapid pace. This setup feels like muscle and intelligence packed together. Finally, the serviced wheels are stored and ready for immediate use, guaranteeing KLM aircraft can land and take off safely. You wouldn't guess the precision and timing required behind every single wheel handled here. Around 11,000 wheels are maintained annually, keeping Schiphol operations smooth and safe. That pull before balancing always looks like a power move. It's clear why a robust system like this keeps planes rolling efficiently day after day. The conveyor belts at Meilo and Gernsheim carry a ceaseless stream of plastics, and every piece is carefully directed through 30 successive sorting stages. German households supply the yellow bins with HDPE, PP, PET, and other plastics, all beginning a journey toward reuse. First, size separation and an air separator distinguish broad categories. Each plastic piece seems to know exactly where to go. Next, a near-infrared scanner reads every item on the belt, guiding compressed air jets to blow recyclable pieces aside, achieving up to 98% purity. Beyond HDPE, PP, and PET, 4 additional plastic varieties are recovered from the same stream. At Systec Plastics GmbH in Eisfeld, The sorted plastics are shredded and cleaned, then repeatedly scanned under near LED detectors to ensure proper color separation before melting and final filtration. Watching the granules reformed into a uniform batch looks almost like plastic magic. The resulting 99% pure granules are packed and shipped. Werner and Merz GmbH in Mainz processes these granules into packaging. HDPE bottles and PP lids are entirely recycled, while PET bottles combine 20% recycled yellow bin material and 80% deposit system PEE TET. This optimized sorting and recycling pipeline closes the plastic loop efficiently. That stream of bottles and lids moving through the facility has a rhythm that's oddly satisfying, like an orchestra of plastics. The recovered materials now serve again, cutting carbon dioxide emissions significantly while sustaining industry needs, proving that thorough sorting and processing can turn household waste into high-quality resources. How can worn tires regain the performance of new ones while reducing environmental impact? Renovado de Neumáticos Rio Pueblo tackles this challenge with a thorough initial inspection process. Every tire arriving at the facility undergoes a thorough evaluation for tread wear, sidewall integrity, and internal structure. This step alone decides whether a tire can be renewed safely or will be retired. Technicians use specialized gauges and visual inspection tools to identify minute cracks, bulges, or weak spots. Tires that pass are cleaned and prepared for the retreading process, while those that fail are sorted for recycling or other repurposing. It's fascinating to see how even subtle imperfections can affect the tire's overall lifespan. The inspection includes measuring tire uniformity and checking for embedded debris that could compromise the retread. A tire that seems fine on the surface might hide critical damage inside. After inspection, approved tires are marked and organized by size and type, ensuring the next stages in the renewal process proceed efficiently. Staff at Rio Pueblo rely on both experience and diagnostic tools to maintain consistency and safety across the batch. Some tires make it through with almost no visible wear. Nature gave them a second chance. The process emphasizes sustainability. Extending tire life reduces the need for new raw materials and lowers waste. It's amazing how a tire can go through these steps and emerge performing like new. By combining careful inspection, organized workflow, and attention to detail, Rio Pueblo ensures each tire's performance, safety, and environmental benefit are maximized. The initial inspection is the cornerstone of a tire's second life, providing the foundation for high-quality retreading. Even the smallest observations during this phase can save significant resources later on. Each Eco Extractor 63 at Eco Green Equipment handles massive mining tires with precision, pulling steel beads cleanly from rims up to 63 inches. The extractor's reverse hook design secures each bead, before the auto-ejector separates it efficiently. That pull is stronger than you'd expect for a single operator handling the machine remotely. Tires arrive at the extractor one by one, where hydraulic arms clamp and rotate them to expose the steel beads. Once clamped, the bead is extracted in seconds, allowing downstream processing to continue economically. The single-person remote control simplifies operations while maintaining safety, even with 125 HP powering the system. Seeing 10 tires processed per hour almost makes it look like the machine doesn't pause for a second. The extracted steel beads are collected cleanly, ready for reuse, while the tire carcasses are sent for further shredding and recycling. Eco-green equipment's design proves that even the largest, toughest OTR tires can be processed quickly and efficiently, turning nearly indestructible tires into recoverable materials. Every leaf spring from Belaretsk is crafted to endure heavy loads reliably. The raw metal gleams under factory lights, hinting at the strength it will gain through precise forging. Material hardness is measured before shaping to ensure optimal spring performance. Operators position massive coil straighteners to ensure each strip is perfectly aligned before heading into the forming press. Automated sensors constantly monitor alignment to prevent slight deviations. This setup feels like muscle and intelligence packed together. As each strip feeds into the hydraulic press, the machine bends the steel into predetermined curves with exacting force. Press speed and pressure are adjusted dynamically based on real-time feedback from the steel's density. Precision dies guarantee uniform arcs for the springs, while high-torque presses maintain consistent pressure. The punch of each press feels more commanding than you'd expect from such a compact floor setup. After initial shaping, springs move to the tempering ovens, where heat treatment stabilizes the steel structure. The controlled furnace ensures elasticity and durability without warping. The duration of each heat cycle is monitored to maintain uniform tempering throughout the batch. Next, the leaf springs undergo grinding and finishing. Rotary grinders and automated brushes smooth edges and eliminate micro-imperfections. That stream of shavings flying out looks almost like popcorn in turbo mode. Workers check each spring for dimensions, ensuring strict adherence to safety and performance standards. Robotic arms assist in handling heavy components, reducing manual strain while maintaining precision. Assembly stations follow, combining multi-leaf springs into complete units ready for automotive or industrial use. Fastening points are carefully drilled and reinforced. After assembly, a final quality inspection tests compression, rebound, and endurance. Springs that pass proceed to packaging and storage, ready for distribution. Throughout the facility, operators coordinate with machines seamlessly, from coil alignment to final inspection, maintaining high throughput while minimizing errors. That pull before bending always looks like a power move. Every station integrates sensors and gauges, providing real-time feedback to maintain uniformity and safety. Belarus's 7 decades of expertise shine through in the careful orchestration of human skill and automated precision. Regular calibration of presses and grinders ensures minimal deviation from design specifications. This is why quality spring production still relies on both tradition and modern machinery. Watching the assembly line of Mitas tire in Malaysia, one notices how each component comes together to form a robust tire. Latex from local rubber plantations is mixed with carbon black and clay to create the rubber compound. The quality of raw materials directly impacts tire performance. Inner liners, carcass plies, bead wires, and belts are carefully layered on the tire building machine, forming the green tire. Some layers look simple, yet each plays a crucial role in safety and durability. After shaping, the green tires move to curing presses, where heat and pressure vulcanize the rubber. Tires are then trimmed, inspected, and finished to meet exact standards. A raw rubber sheet transforms into a tire capable of withstanding thousands of miles. The final inspection ensures performance, uniformity, and safety before shipment.
The USS Billings slides sideways into the water, a careful orchestration of weight and balance engineered for war. At the christening, naval crew and engineers guide the massive hull as it moves from dry dock to river. Stabilizers adjust, supports release, and the ship's momentum takes over. That tilt right before it hits water surprises with how smoothly it transitions. Once afloat, the warship floats steadily, ready for outfitting and sea trials. Seeing all that steel glide calmly shows the engineering behind naval operations. Feel the tension as anchors are maneuvered into place, each cable tension carefully monitored to prevent accidents. Crew members move with deliberate focus, anticipating every shift of the chains. That pull looks heavier than expected for a vessel this size. Signals are exchanged between deck and bridge to confirm accurate placement. The anchors are carefully lowered, each movement deliberate and controlled. You can almost feel the precision in every adjustment. Once settled, the team checks the chains and secures them for the next operation. Tasks continue methodically, maintaining safety and efficiency throughout the process. The anchor stays calm while the machine wrestles it into position. Human skill and coordination dominate this demanding deck operation seamlessly. Leclerc XL and Leopard 2A7 deliver armored force built around heavy impact and structured crew control. The Leclerc XL, weighing roughly 56 tons, moves with a responsive feel thanks to its compact 3-man crew configuration, and that quick surge forward catches you off guard the first time. Its 120mm gun launches explosive shells with controlled recoil that keeps the barrel aligned for rapid follow-ups. A 12.7mm machine gun and a 7.62mm secondary mount provide layered fire coverage, and the way those bursts carve clean paths almost feels like the tank is clearing its own lane. To prepare for engagement, The Leopard 2A7 brings its 64-ton frame into position, using a 4-man team that balances observation and targeting roles. Its 120mm cannon delivers assertive punch at long distances, while twin 7.62mm machine guns handle close threats efficiently. That moment when the turret shifts feels like pure intent in metal, giving the whole vehicle a sense of controlled strength. Feels like the armor is ready to lean into any challenge without hesitation. Both platforms rely on coordinated crew actions to stabilize, load, aim, and fire, turning raw mass into directed force across the field steadily. Tons move through coordinated lines at Ashok Leyland's Hosur 2 plant, showing how its layout supports steady vehicle production. Line 1 handles 2.5 to 7-ton builds with a 3.6 6-minute takt, and that pace hits quicker than you expect. Lines 2 and 3 take on 9 to 49-ton models with an 8.15-minute takt, and the jump between sizes feels almost like switching worlds. Line 4 focuses on defense vehicles, backed by the Skill Development Center team. Though logs are pushed hard by the timberman's separate laster, they still move in a steady flow that keeps the yard organized. The machine positions its grapple to pick mixed timber, then shifts each batch onto sorting lanes. That grab looks stronger than expected for this compact setup. Operators guide the loader to release each stack cleanly. Feels like the machine makes sorting look effortless. Its pass clears transport. Vehicles pushed to their final days still manage to offer solid value. And at Bessler's, the way each car gets pulled apart while still delivering something useful creates a small contrast that draws you in immediately. You get a faint sense that every shell still has one last job to do. The whole setup looks tougher than they pictured. That sturdiness almost feels like the yard built itself for heavy endings. A loader shifts each unit into place so the gripping arms can lock onto the structure cleanly. Hydraulic pressure readings are carefully calibrated to ensure each grab exerts just enough force without damaging key components. The alignment alone shows how routine doesn't always mean effortless. The way the jaws clamp down might make you blink. That snap carries a kind of certainty people don't expect from scrap work. That clamp always feels like it lands with serious intent. A tiny pause here sometimes gives the scene a bit of tension. The robotic arm's rotational torque can adjust dynamically to handle different panel thicknesses with precision. You could say the machine moves like it already knows the weak spots. Batteries, airbags, and leftover electronics come out quickly. The flow of removed parts almost feels like pages being torn out of a thick book. That the pull-out speed is wild, the weight drops, and the shell becomes easier for the arms to manipulate. Moments like this remind you how fast a vehicle becomes just material. There's a quick shift where usefulness separates cleanly from bulk. Once emptied, strong claws grab the doors, hoods, fenders, bumper beams, and structural plates. Each claw is reinforced with high-strength steel, allowing repeated heavy lifts without structural fatigue. The machine twists, tugs, and pries them loose. You might think the panels never stood a chance. Those bends carry more history than most people imagine. Panels fall with abrupt jerks, revealing the internal structure beneath. That reveal always feels sharper than expected. This is the kind of moment where someone might mutter "no way" under their breath. The exposed frame allows the grabber to reach deeper. The engine block and transmission become the next targets. That shift toward the drivetrain always marks a turning point in the teardown. The arm digs, shakes, and pulls until the whole assembly releases in one heavy lift. These cores, loaded with valuable metals, usually head to buyers that specialize in rebuilding or reclaiming alloys. You notice how the value of the car seems to regroup itself in these heavy pieces. Interior parts still hanging on, seats, panels, dash structures, wiring looms, get yanked or crushed out piece by piece. A fast rip here makes the scene feel oddly energetic. Some rips almost feel like the cabin giving its final breath. Everything inside weakens under pressure, dropping until little remains but the outer shell. How fast stubborn parts give up. You'd think some pieces would resist longer, but they fold without hesitation. Some drops hit the ground with a weight that surprises people. The collapse happens in stages until the roof and sides cave toward the center. Each stage feels like another chapter closing. You might feel a tiny moment of respect seeing how nothing is wasted. Seeing the final stacks lined up almost feels like reaching the end of a long story that instantly restarts. That final lineup often makes visitors rethink how recycling loops actually function. The entire flow turns what looks like an empty shell into streams of material ready for reuse. How the hydrodynamic screw at this micro hydroelectric plant maintains level control through variable speed draws interest for its simple but effective design. A 3.2-meter hydrodynamic screw shows how its wide spiral uses the 1.83-meter drop to turn steady flow into useful rotation. The system relies on the screw's broad channel to move water smoothly toward the generator, and you might react a bit when the spiral keeps pushing that much water with such consistency. With a maximum capacity of 4 cubic meters per second, the installation holds upstream levels stable through its variable speed setup. Water enters the trough, filling each section of the screw so torque can build along the shaft. The permanent magnet generator engages once rotation stabilizes, converting the motion into electrical output. The controller adjusts the frequency converter so speed shifts match incoming flow.